Today we are trying to integrate this function x squared over square root 9 minus x squared by the trigonometry substitution. First of all, we draw the right angle triangles with one side is equal to square root 9 minus x squared. So let's see, this side is 9 minus x squared. Because the 9 is in this way, so this side must be equal to 3. And this side is equal to x. And now we are trying to see if sine theta, secant theta, or tangent theta is equal to x over a. In this case, x is equal to 3. So the angle theta must be this one, because the sine theta is equal to x over 3. And if sine theta is equal to x over 3, x must be equal to 3 sine theta. And dx is equal to 3 cosine theta d theta. Then we substitute into the x squared over square root 9 minus x squared. We got x squared is equal to 3 the square sine square theta. And then dx here is equal to 3 cosine theta d theta. So it's multiplied by 3 cosine theta d theta. Over 9 minus x squared is equal to square root of 9 minus 3 sine theta square. So it's equal to 9 sine square theta times 3 cosine square theta over square root of 9 minus 9 sine square theta. And then it's equal to 27, and take out 3 outside here, so it's over 3. This one should be sine square theta cosine theta d theta. And over square root 1 minus sine square theta is square root of cosine square theta. And we know that cosine theta is not equal to 0, so this one could be cancelled out. And finally, we get the integrations of 9 sine square theta d theta. So what is sine square theta? From the trigonometric identity, we know that the sine square theta is equal to half 1 minus cosine 2 theta. Now we substitute this one into here. We got 9 half 1 minus cosine 2 theta d theta is equal to 9 over 2 integration of 1 d theta minus 9 over 2 integration of cosine 2 theta. We take the integration, we have 9 over 2 theta minus 1 half of sine 2 theta per c. And don't forget the per c. And from the trigonometry identity, we know that sine 2 theta is equal to 2 sine theta cosine theta. And then we substitute into this one here. We have 9 over 2 theta minus 1 half 2 sine theta cosine theta. Finally, we have to reconvert the theta into something of x. From the right angle triangles, we know that the sine theta is equal to x over 3, and the cosine theta is equal to square root of 9 minus x squared over 3. Finally, we have the integration of x squared over square root of 9 minus x squared dx is equal to 9 over 2 the arc size of x over 3 minus x over 3 and square root 9 minus x squared over 3. And don't forget the per c, the constant. In the next example, we are trying to integrate x squared over the square root of 9 plus x squared, and we draw a right angle triangle. And the longest side must be 9 plus x squared. The two sides must be 3 and x. This angle is theta, so that we have tangent theta equal to x over 3. And then x is equal to 3 tangent theta. And dx is equal to 3 secant square theta d theta. We substitute here into this integration. Then we have x squared is equal to 3 square tangent square theta. And d theta is equal to 3 secant square theta d theta over the square root of 9 plus 3 tangent theta square. So it's equal to 27 over 3 the integration of tangent square theta, secant square theta, d theta over the square root of secant square theta. And if secant theta is not equal to 0, we can cancel this term out. We will get 9 the integrations of tangent square theta, secant theta, d theta. So we know that tangent square theta is secant square theta minus 1. So we have 9 secant square theta minus 1 multiplied by secant theta d theta. And then we get 9 secant cube theta d theta minus 9 secant theta d theta. So now we have to solve for the secant cube theta, the integration of it, and the integrations of secant theta. We solve for the secant theta first. We will rewrite the integration of secant theta into the following. We multiply the whole terms by secant theta plus tangent theta. And then we have the integration of secant square theta plus secant theta tangent theta over the secant theta plus tangent theta d theta. And we assume that secant theta plus tangent theta is not equal to 0. Then by substitution, u equal to secant theta plus tangent theta and du equal to secant theta tangent theta plus secant square theta d theta. We can see this is equal to here. So the above integration will be changed into the integrations of du over u, and it is equal to log u plus c. And of course, u is equal to secant theta tangent theta. Then we got the answers of the integrations of secant theta. Now we are going to solve the integration of secant cube theta. To solve the integrations of secant cube theta d theta, we rewrite the equation into the integration of secant theta multiplied by secant square theta d theta. And then we use the equation integrate u dv equal to uv minus integrations of v du. And we let u equal to secant theta, dv equal to secant square theta d theta. Then du equal to secant theta tangent theta d theta, and v is equal to tangent theta. Then we have integrations of u dv is equal to uv minus integration of v du. And we substitute uv integration of v du. Then we have secant theta tangent theta minus the integrations of tangent theta, secant theta, tangent theta d theta. This is equal to secant theta tangent theta minus tangent square theta secant theta. And tangent square theta is equal to secant square theta minus 1, so we get this. And then we have this here. Now if you can see on the left hand side is the integration of secant cube theta, and here is also the secant cube theta. So we have the following. 2 of integration of secant cube theta d theta is equal to secant theta tangent theta plus secant theta the integration. And from the above we know that this one should be equal to log of secant theta plus tangent theta. And finally, the integrations of secant cube theta is equal to half of secant theta tangent theta plus log secant theta plus tangent theta. We finally solve this integration. And also we have the integration of this. So we combine these two results into this one. We got the final solution. The solution is a little bit long. We have 9 multiply half secant theta tangent theta plus log secant theta plus tangent theta, and minus 9 log of secant theta plus tangent theta. And don't forget the plus c. Finally, we have to change this theta into something of x. This is the right angle triangle. So secant theta is equal to square root 9 plus x squared over 3. Tangent theta is x over 3 plus the log of secant theta, square root 9 plus x squared over 3 plus tangent theta, x over 3 plus 9 log of secant theta, square root 9 plus x squared over 3 and plus tangent theta, x over 3, and of course finally plus c. this is the final solution. So that's for today. If you like my videos, please subscribe to my channel. Thank you and have a good day. Bye bye. Adios. Hasta la vista.